Hey, it's Dr. J, and I'm sad to say that I was alerted to a mistake in 4.6 Part 1, Example 6, had a fatal flaw causing my answer to be incorrect. So I'm here with you today over spring break just to make amends for that and redo the problem correctly. So this is just going to be a one problem video. You can use this to amend your previous lecture video that you might have already viewed. So this was the compound interest formula. We have the amount. Let's see if I can fit it over here. The amount is the principal times 1 plus the interest divided by n to the nt. Everything's the same as it was in the original problem. The future amount is A. The present value is P, or the principal. The interest rate is R, and that'll be as a decimal, 0.17. And compounded daily is our N, will be 365 days a year. So we'll plug everybody in. We have our 8,000 is equal to 5,000 times 1 plus 17% as a decimal divided by 365 to the 365t. We're solving for t. How long will it take? That's going to be our t value that we're trying to solve for. All right, let's go ahead and do the decimal value first. This is where I made my fatal error. 0.17 divided by 365, and then plus 1. So the correct value for this argument is 1.000. That's where the mistake was. Thank you to the student that brought this to my attention. So that I don't embarrass anybody, I will keep his or her name anonymous. But if you're out there in internet land, you know who you are. Thank you very much. So it is 3 zeros. There was the mistake right there. I think I had mistakenly written only 2 zeros here when I simplified that. So now I'm dividing both sides by 5,000. That's going to be 8/5, which is 1.6. And in transcribing this, be very, very careful. In fact, I'm just reminding myself of that as well. You know, I got a little bit spoiled having you all in front of me in class every day, Monday through Thursday. Or if I made that kind of mistake, I'm sure somebody would have mentioned it to me at the time. But when you do notice mistakes, I appreciate your emails, and you can let me know as soon as possible. So now, the rest of the problem should be pretty smooth sailing. We're going to take the log of both sides. I don't recall if I had used the natural log or the common log. I'm leaving a blank here for that 365 that's going to come down. So the exponent, 365t, comes down to the front and becomes the coefficient of the logarithm. So now we have log of 1.6 equals 365t times the log of, and be careful, 1.000465753. I'm just keeping that value on my calculator as an insurance policy to make sure I don't screw this one up again. Okay, let's see if we can finish the problem here. Here's a little trick I like to do. We're solving for t, so I just like to rearrange the order here using the commutative property of multiplication. So I can just reverse the order there. And I'm actually going to write it like this just to save space. T times 365 log of 1.000465753. And then since log 1.6 is much smaller in terms of space, it's actually a larger number, but I'm going to squeeze it over here in this little space that I have in the right-hand side. So I've got log of 1.6. There we go. And my goal is to solve for t. At this point, I'm actually going to use my calculator and figure out what these logs are. So let's do log of 1.000465. I've kept that on my calculator, so we'll do log of that and then multiply by 365. So the coefficient on this side, on the t side of the equation, is 0.073812874. Now, if you've got a fancy calculator, you can just save that number in your calculator and not have to delete it. I don't. I'm just going to clear this sucker out and start over again. So I've got 1.6. That's why I'm writing everything down. Then take the log. I get 0.204119983. Probably doesn't matter at that point. Here, let me see if I can squeeze that in. 0.204119983. There we go. Okay, now it's basically a linear equation in one variable t, so we just divide both sides by the coefficient. And again, I know I say this a lot. If you already have these values stored in your calculator, you can just press divide and you're good to go. Okay, so I've got 0.20411, et cetera, divided by 0.073812874. And that comes out to be 2.76537.102. We're going to round this to 4 decimal places, so 2.7654. Our dictator is a 7, and so that's going to round the 3 up to a 4. And this is years. So that's how I want you to enter the answer on the computer. If you were talking to somebody, it's approximately 2.8 years. You could even say about 3 years, but I'm going to go 2.8. On the computer, you would enter 2.7654 years. I think in the previous problem, I came out with a number of months. I don't remember. It was like 3 months or something, which just seemed ridiculous. I really should have gut checked that. And, you know, when you do mathematics, you should have some sort of an instinct about whether or not your answer makes sense. And sometimes that instinct, drives you to change your answer, and sometimes we don't listen to our instincts, as I did not. Okay, folks, have a happy spring break. I'm going to keep posting these corrections and homework requests if you have them. The final part 3 of the applications, 4.6, will come on Monday. If I get it done sooner, I will let you know and post it up there on Canvas. Otherwise, happy spring break. Bye.